Hi children, good morning. How are you? Yes, I hope all are fine. Yes, very good. Then today we are going to discuss about in chemistry unit 12 periodic classification of elements. Okay, so periodic classification of elements. So what is element? What is element? All of you say the answer. So you studied in the last 11th unit and 10th unit. So what is element? Yes, very good. A substance composed of atoms having an identical number of proton in each nucleus. Okay, this is called element. Okay, so now in the periodic classification of elements, in how many elements present in the periodic table and which groups of present in the periodic table, then in the periodic table elements, how to separate the elements. Okay, so study the in this topic study about the periodic classification of elements. Okay, so in your front page number, so all of you take your science book and page number 138. Okay, so in small introduction, so in the periodic classification of element in 1800 only 31 elements were discovered. Then in 1865 the elements have 65 elements were discovered. Now currently 118 elements have been found. So in the early concept, before the modern periodic table came, three scientists have discovered in some elements or arranged the tables according to their in nature. So some elements is very hard and some elements is liquid, some elements is solid. So in the classified the elements and separate the arrangements of the group. Okay, so who are the three scientists? Okay, so in the first scientist is Dobrinier triads. Okay, so the triads, the tri means three. Okay, tri means three. So the Dobrinier triads. So in 1817 Johann Wolfgang Dobrinier, he is found in the triads rule. He is the German chemist. So he arranged the elements into group containing three elements. Okay, he arranged the elements group containing three elements are arranged in each group. So in this triads law, when the three elements in a triads are arranged in the ascending order of their atomic mass. Okay, ascending of the atomic mass. So the atomic mass of the middle element is nearly the same as average of atomic masses of the two elements. Okay, so all of you see that in this table, so all of you see the table number 12.1. Okay, so then the first group, so in the triad group 1 and triad group 2, triad group 3. So in the group 1 element is lithium, Li, sodium, Na, potassium, K. So the atomic mass lithium 6.9, sodium 23, potassium 39.1. Then the triads group 2. So the element chlorine Cl, bromine Br, iodine I. So the atomic mass chlorine 35.5, then bromine 79.9, then iodine 126.9. Then triads group 3. So element is calcium Ca, then strontium Sr, barium Ba. So the atomic mass calcium 40.1, then strontium 87.6, then barium 137.3. So he arranged the elements into group containing three elements. Okay, this is called the triads law, in Dobrinier triads law. Okay, so in the three elements is arranged in the ascending order of the atomic mass. So you see the atomic mass number 6.9, 23 and 39.1. Okay, so this is the arranging in the ascending order. So arranged in the ascending order of their atomic mass. So in the atomic mass of the middle element, okay, atomic mass of the middle element is nearly same to the average of the atomic masses of their two elements, because you calculate the lithium atomic mass is 6.9 plus potassium atomic mass is 39.1. Okay, so calculate 6.9 plus 39.1 is divided by 2. Okay, so total 46.0 divided by 2. So 646 divided by 2, the answer is the middle of the element 23. Okay, so in the middle of the element, the same average of the atomic mass of sodium 23. So this concept is the Dobrinier triads law is the ascending order of the atomic masses of the elements. So each group is containing 3 elements are arranged. So this is the Dobrinier law. So then the limitation of Dobrinier law. Okay, so at the time only the elements in the 3 blocks should be detected by the law. Okay, so all elements could not be classified in the law. So all elements, okay, all elements means metals and non-metals and metalloids. So all elements could not be classified in this law. Then the elements having very high or very low atomic masses, the law is unable to use us, because sometimes in 3 elements are arranged in a group in the ascending order, but the elements are arranged in the descending order does not obey in this Dobrinier law. So in these 3 concept of limitation of the Dobrinier law. So in the next law is the Newland law. So Newland law is otherwise known as Octavius laws. So in this Octavius laws, oct means 8. Okay, oct means 8. So in the triads law, tri means 3. So the elements are arranged in 3 elements. Then in the Octavius law, so the oct means 8. So that the elements is arranged in 8 elements. Okay. So in the next, scientist is had to continue working towards this and try to find the way of classify these elements, so that our study could be easier. So John Newland, so in the year is 1866, so it's only 56 elements are found. So increasing the atomic mass, okay, these 8 elements are increasing the atomic increasing order of atomic mass. So that atomic mass arranged system, okay, arranged system is like Indian music system. So in the Newland, he is very musical interesting man. So Indian music systems is Sari, Hama, Pada, Nisa. So every 8 element is similar property to the one element. Okay, every 8 element is similar property to the one element. So see this the Newland law. So all of you see the table number 12.2. Okay, so every column is 8 element. So first column is hydrogen, lithium and germanium and palladium, carbon, nitrogen and oxygen. Then second column is fluorine, sodium, magnesium, aluminium, silicon, phosphorus and sulfur. So next, so in this atomic mass number is increasing order of atomic mass. So every 8 element is similar property to the first element. So in this first element is hydrogen, in the 8th element is fluorine. So in the hydrogen and fluorine is the similar property of the same element. So hydrogen and fluorine is the similar property of the element, and lithium and sodium is the similar property of the element, and germanium and magnesium is the similar property of the element, and palladium and aluminum is the similar property of the element. So every 8 element is similar property to the first element. Okay, then in this Newland-Octavus rules limitations. Okay, so in two different elements are arranged in the placed in the same places. For example, see the fourth column is cobalt and nickel. So one column is filled with the element in two elements. Okay, so in this case, so the two elements placed in the same place, so that 8 rules. Okay, so in this Octavus rule is not obey in this concept. So in the next one, the element of completely different in nature. So that Triad's law is arranged in metals and non-metals, but in this Newland law is metals and non-metals is arranged in collapse. So the elements is completely different in nature or placed in one place. Example, cobalt, nickel, lead, platinum and iridium are arranged in the halogens group. Then in this law is not possible for element that had atomic masses higher than calcium. So in the calcium atomic mass is 17. So in the atomic mass of calcium is 17 is higher than the other element. Then this table is reserved only the 56th element. So there is no space for element to be find in later element. Later elements means is the halogen elements and then other uranium 56 after the 56 elements, because now the current elements is 118 elements. So in this table is reversed only 56 elements. So there is no place for the element to be find in later. Then the later element is inert gases group. So in the inert gases, ninth element is similar to the first element. Okay, the inert gases element is ninth element is similar to the first element. Example, in the neon is between the fluorine and sodium. Neon is between the fluorine and sodium. So this is the limitation of Newland-Octavus rules. Then Mendeleev periodic table. So in this Mendeleev periodic table, so in the Mendeleev periodic table, in the year is 1869. He is the Russian chemist. So in the elements is 56 elements are present. So he is arranged the elements in physical and chemical properties of the element or the periodic function of their atomic masses. So all of you underline the line. The physical and chemical properties of the elements are the periodic functions of their atomic masses. So what is physical property and chemical property? So that physical property means that element is solid, liquid or gas, and that elements having melting point is high or low, and then character is ductility and then hardness. So these are the physical properties. Then the chemical properties. That chemical properties means that one element is react with in the presence of air and react with water and many reactions. So in the physical property is changing the elements into the physical. Then the chemical properties is the without changing the physical functions. So this is the physical property and their chemical property. So all of you underline. So the physical and chemical properties of the element are the periodic functions of their atomic masses. So he arranged in 56 elements. So this is the Mendeleev periodic table. So see the table. So all of you see the table number 12.3. So in this table have 7 horizontal row. Okay, 7 horizontal row is called period. Then 8 vertical column is called group. Okay, so the horizontal row are called period and vertical column is called group. So how many periods are present? Yes, seven periods are present in the horizontal row. Then vertical column is 8 vertical column is present in the periodic table. So each group has 2 subgroup. Okay, each group have 2 subgroup. So all of you see is A and B. So first group and second group is A and B. Because A is the react with the element is oxide and hydrogen. So A and B. So each group has 2 subgroup A and B. So all the elements present in a group to have similar property. So for the first element or probably is classified, the element of similar property were placed in same group. So in the hydrogen is the first group and lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. This is the second period elements. Then third period elements is sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. So this is the third period elements. Then fourth period elements. So in the fourth series and the second series. So in the A and B column is potassium and copper. So there are 2 elements are present. Then next calcium Ca and zinc Zn. So in this 2 elements are present. So next one scandium and gallium. So the 2 elements are present. So in this table is arranged in the metal and non-metals and then the transition metals in the subgroup of B. So we are discovered in the atomic mass 14. Okay, atomic mass number 14. So which elements are atomic mass number 14? Yes, that elements is nitrogen. Okay, so nitrogen, the atomic mass number is 14, but the Mendeleev periodic table is arranging the elements is beryllium atomic mass number is 9. Okay, beryllium atomic mass number is 9. So beryllium is arranged in the proper place. Beryllium is arranged in the proper place. So it is the increasing order of atomic mass number is the ascending order of the atomic mass number in their elements. So in some elements could not arranged in the proper place. So beryllium is arranged in proper place. Then some elements, example is copper, zinc and gallium, that elements is does not arranging in the proper place. Then in this table column were left vacant space. So in this left side is eighth group element, eighth group in the transition series. So some vacant spaces available. Yes. So in this table, table column were left vacant some place for the element to be found in the future element, future finding the elements. Okay. So in the aluminium, silicon below the elements, that name is ega alumina and ega silica. Okay, so where is aluminium, silica? Yes, Al is aluminium and Sa is silica in the third period and group 3 and 4. Okay, third period and group 3 and 4. So the aluminium Al atomic mass number 24.31, then silica atomic mass number 28.09. So in these elements, so aluminium and silica below the elements are the name is ega alumina and ega silica. So in this table is motivation to experiment in chemistry. Then the next one is the Mendeleev limitations. Okay, Mendeleev's periodic table limitations. So the different properties of element arranged in a group. Okay, different properties of elements arranged in a group. For example, hard metal and soft metal. So in the hard metal is copper and silver. Okay, copper and silver. So copper Cu, silver Ag. So the fourth period and fifth period, copper Cu and Ag is silver. So this is the hard metal. Then the soft metal is sodium and potassium. So in the same third and fourth period is the A subgroup of A. So sodium Na, potassium K. Okay. So in the sodium potassium is the soft metal and copper and silver is the hard metal. So the different metals is arranged in the same places. Then no proper position is given the hydrogen element. So hydrogen is arranged in the metal group. So hydrogen is does not metal. Hydrogen is a non-metal. Okay, hydrogen is a non-metal. So hydrogen is arranged in the metal like lithium, sodium and potassium. Okay, hydrogen is arranged in a metal groups, but hydrogen is a non-metal. So this is one of the limitation. Then the elements is arranging the increasing order of atomic mass was not is followed through the cobalt and nickel and tellurium and iridium. So the cobalt and nickel, okay, cobalt CO and Ni nickel. So in all of you see in the last eighth group, okay, eighth group cobalt and nickel. So all of you see cobalt is the atomic mass number 58.93. Then nickel atomic mass number 58.71. So it is the decreasing order. So in the increasing order of atomic mass is not followed throughout the table. So no places for isotopes in the periodic table. So isotopes and isobars. So the isotope means what? So isotope means same that element, same atomic same atomic number and different atomic mass number. For example, chlorine. So chlorine have same atomic number 17 but different atomic mass number 35 and 37. So this is the isotopes. Okay. So in three yearly concept, one is Dobrinier triads and Newland octavus and Mendeleev periodic table. Okay, this is the yearly concept of periodic classification of elements. So this is the periodic table. So first you see the group. Okay, so how many groups? So 1 to 18 groups. So this is the vertical column. Okay, vertical column. So in the increasing number of atomic number is the vertical column is left to right to left. In this column is group. In this column is called group. So how many groups are present in the periodic table? 18 groups are present in the periodic table. So that elements are placed in the period is based on the number of shells in their atoms, number of shells in the elements or atom. So in the vertical column in this periodic table is started in, so in the left to right in this called period and top to bottom is called column. So in the horizontal row, okay, horizontal row is called period and vertical column is called group. So in the top to bottom is hydrogen, hydrogen is first group and beryllium is second group and scandium is third group and titanium fourth group and fifth group is vanadium, sixth group is chromium, seventh group is manganese, and 8th group is iron, and 9th group is cobalt group. So these 3 to number 12, 3 to 12 number is transition group, okay, transition metals. So in the first 1, 2 and the 12, so these are the metals in transition. 3 to 12 is a transition metals. So in the first group is alkali metal, then second group is alkali earth metal, then 13th group is boron family, then 14th group is carbon family, 15th group is nitrogen family, then 16th group is oxygen family or chalcogen family, then 17th group is halogen family, then 18th group is noble gases or inert gases. So these noble gases or inert gases groups present in the element helium, neon, argon, krypton, xenon and radon. So in these elements are stable electronic configuration. So these elements are stable. So in these elements is arranged in the electron is completely filled in the shell in the atoms. So this is the group in the periodic table. So in the vertical column top to bottom is called group. So 18 groups are present in the periodic table. So first one alkali metal, second one alkali earth metal, third to 12 is transition metal, 13 is boron family, and 14 is carbon family, and 15 is nitrogen family, then 16 oxygen or chalcogen family, then 17 fluorine family, and 18 is noble gases or inert gases group. Then next one is the period. So 7 periods are present. So in the left to right column is 7 period is present in the periodic table. So first period is hydrogen and helium, okay, hydrogen atomic number 1 and helium atomic number 2. So in the first period, very short period, only 2 elements are present in the period. Then the second period is the shortest period. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. These elements are present in the second period. So in the next one, third period also short period. These elements sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon, these elements are present. So how many elements are present in the first period? Yes, only 2 elements are present in the first period. Then how many elements are present in the second period? 8 elements are present in the second period, and the same third period also present in 8 elements. Then the fourth period and fifth period, sixth and seventh period is the longest period. So this period have 18 elements are present in the period. Then in the sixth period and seventh period is atomic number 57 and atomic number 89 is lanthanide and actinide, LAAC, okay, LAAC. Then you see the next atomic number 72. So 57 to 72. So in between the elements is arranged in the bottom of the periodic table is lanthanide series 6. So these groups are called lanthanide group. Then in the seventh group actinide is atomic number 89. So next you see the atomic number 104. So 89 to 104, in between the elements are arranged in the bottom of the lanthanide series elements. So in these elements are called actinides series. So lanthanide series and actinide series. So in this group is separated in the shell is S shell and B shell, S, P, D, F. So this is the subshell of arranging the electrons in the new atoms. Okay, so in the electronic configuration, so the elements are arranged in their atomic increasing order of atomic number and their electronic configuration. Okay, so what is the electronic configuration? The distribution of electron in different shell. Okay, the distribution of electron in different shell. So in this shell is further classified into the subshells. So the subshells means S, P, D and F. So the electron is distributed. So in the hydrogen in the first shell is filled 1 as 1. Then helium 1 as 2. Then goes to the second layer. In the second period is lithium and beryllium 1 as 2 and 2 as 1 and 2 as 2. So the electrons is distributed in the shells. Okay, distributed in the cell is called the electronic configuration. So in the electronic configuration is based on the periodic classification of the elements. So there are 4 blocks are namely in the periodic classification. So first two group, okay, alkali metal and alkali earth metal. So in the first two group is called S block element. Then 3 to 12 in the transition metal is called D block elements. Then boron family and carbon family and nitrogen family, then oxygen family or chalcogens family and halogens family and noble gases family. These groups are called B block elements. Then in the bottom of the lanthanide series and actinide series, this group is called F block elements. So this is the classification of elements. Okay, so today we study about the topic is early concept is Dauber-Renier law, Triad's law and Newland law is Octavius law, and then Mendeleev periodic table is period and group. Then the classification of the block wise in the elements. Okay, so now your homework. So in the first question, define the Dauber-Renier triads law and then the Mendeleev periodic table in the new modern periodic table law, and then the features of Mendeleev periodic table and then limitation of Mendeleev periodic table. Okay, this is your homework. So all of you study and write. Okay, thank you children.